Okay, I want to show you this diagram. I have three different diagrams here. In the first one, I have 9 areas. Okay, here, 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 and here. Let me take off the, once again, the autofocus. Let me remove that. So now I'm going to have each area. So that'll be 36 total areas. Okay, 36 total areas in each one. Each one is a little bit different. But before I do that, I want to show you this. Okay, each one of these squares, okay, each one of the squares, and if you look at Rubik's Cube, a face is supposed to be 9. So I should assume that each one of these will have a 9 face. But I'm not going to do it that way. I'm going to call it a 4 face. Okay, I'm going to call it a 4 face. And I'm going to put the color, let's say the color light blue inside of, let me get that over here, light blue. And I'm going to get light blue in all of these. When I separate this, okay, I'm going to get separation in space. So if each one of these was valued at 9, I would have 81, 81, 81, and 81 is 324, 18 by 18. Okay, but it's not 9. I'm going to keep them, okay, I'm going to keep them as only a 4 space. You notice there's 2 extra squares I put over here. So each one of these will be a 4 space. 9 times 4 valued space equals to 36, 36, 36, 36, which is a total of 144, okay, which is 12 times 12. So now I'm going to have 2 there. They're coming in as yellow. I'm going to switch them back. I'm going to have 2 here, 2 here, 2 here, okay, and 2 here. Now they should all be blues, so I'm just going to repaint them to blues. They're not big enough. I should have made them a little bit bigger. Okay, and now I have 1, 2, 3, 4, 5, 6. I have to go up 2, 4, 6. So I'm going to have 6 here, 6 here, 6 here. In fact, I'm going to make it easier. I'm going to put them all down while I do this. Okay, and in fact, I'm going to do it even easier. I'm just going to copy that and paste and then rotate it to the right. I'm going to put a whole slew of these here. Then I'm going to paste and I'm going to put a whole slew of them here. And then I'm going to paste and I'm going to put a whole slew of them here. So I have 6, 6, 6. And then below the line, I have another 6. 6 and 1, 6 and 1, 6 and 1, 6 and 1. So it's 24 plus 1. So now what we would have, okay, is 36, 9 times 4, 36, 36, 36, 36, 108, 144. And 6 is 150, 156, 162, 168 hours in the week, and the 1 rotation center. This will be a total of 13 by 13, or 169, or the same amount of area spaces on the Monopoly board. The reason for the same amount of spaces and the Monopoly board being 169 areas is because it takes a linear, right? Linear. There's rectangular spaces in Monopoly. If you take a look, they're not square boxes. So the minimum amount of area space that you can use in Monopoly, understanding that each corner in Monopoly is squared off, meaning that the corners in Monopoly will each be 4 and every other space will each be 2. Although it can be 2 by 3, the minimum you can make it is 2 by 1 on a property and 2 by 2 in a corner. Okay, so this scenario over here shows me this reality. In the center, we have 1 around 1, okay, but this 1 around 1 is 1 area space, 2 area space, 3 area space, 4 area space. 5, 6, 7, 8, and 1, leaving you with your digital 9. It'll be 9. Then in the larger spaces, okay, this is your minimum. Now, if I was to take another and cut this over here, do you see where I'm cutting out, I'm cutting out around. Can you actually see this? Can I try and, I'm going to see if I can move the board and get this a little bit bigger for you so you can see, unless it's for me that I can't see. Okay, let me do it this way. Maybe you can see it a little bit better. So now in this area, okay, this size, there's going to be another block here, another block here, another block here, and another block here. There's going to be 3 blocks here, 3 blocks here, 3 blocks here, and 3 blocks here. 3, 6, 9, 12. Okay, 3, 6, 9, 12. There's going to be 1 here and 1 here, 1 here and 1 here. So it's 12 and 4 equaling to a total of 16 that surrounds this 9. And then we're going to go into the next area. And we're going to do the same thing over and over. I don't have all the numbers with me right now, but I just want to show you what happened when we separated all the numbers and we're not working the numbers the way we're working the numbers over here. Okay, the way we're working the numbers over here. Yes, I put up a little sign at the top. It says over here, please donate if possible, tacpans@msn.com. Any amount will be nice. I want to thank you beforehand for those who can, and for those who can't, just make sure this work gets out, because that's going to be good enough for me. I started with nothing, and that's the way it goes. Now in this first area, I flipped all the boxes so 1 is in the center. We're not going to count squares anymore. Then I went, and then 5 is on the outside. And then I went, and then 9 is on the outside. When you have 9 on the outside, in between, on the bottom row, you have 8, 7, 7, 8. When you have the side road, you'll have 9, 6, 3, 3, 6. When you have the same road and the same road over here. So these are all going to be numeric realities. It's going to be 9 with 6 and 6. Now all of these are going to get now colors. They're going to get colors because according to roulette, there's a change in the color schematics. According to 2 different kinds of horse racing, there's another color schematics. According to the game of pool, there's another color schematics. And remember, in the game of pool, the 1 and the 9 are both yellow. So yellow, 9, encompasses the outside and the inside. In pool, the black area we're going to go as gray. Okay, in pool, the 6 ball, if I remember, is green. The 7 ball is brown or turquoise-ish. Whoop, I have to take that away. I'm not sure why it's doing that. It keeps coloring me up 2 colors. Why in the, oh, because there's something missing here. There's a line missing. I'm going to fix that in a second. Okay, just going to fix that up, and we're going to get that. Could be this actual color. Is it that color? Okay, yeah, that's the actual color of the 7 ball. The 3 ball is red. So we're going to color in the 3 ball red. Well, same difference over here. We have a line problem. I'm going to fix that line problem in a second. We're going to go back here and put the 3 ball as red. We're going to put the 5 ball as orange. And here is the 5 ball being orange. And the 5 ball being orange, and the 2 ball is blue, whoa, we gotta fix that now, 2 ball is blue. And now we are going to get the 4 ball, if I remember, is purple. And whoop, again, we have the same problem. We're going to fix that. Four ball was purple. So we have the 4 ball purple. And the rest of this is the 1 ball. Now, we can look at this as darts, where the center part over here gets a certain amount and what goes around the 1. So where are we going to count the center of the dartboard? Now, this is the color schematics of this. Now, if I was to be running in Tesla's power numbers, we are going to make 1, 4, and 7 the same color as yellow. So we are going to go and put yellow in 1, 4, and 7. Where's number 4? I shouldn't have done that over that yellow line, but I'll change that yellow line to, whoa, just let's take that away. We're going to go and get a, let me see, not a white. I'm going to have to take some other color. Okay, let me use that color for this schematics. Changing this yellow line over here to a different color, right? So this is what we would actually look like, 1, 4, and 7. And this is what Tesla would change us into. I'm going to be doing the same thing with pi. Now, the 6 color, the 1, 4, 7 I changed. Now we're going to change 2, 5, and 8. So we're going to change the 2, 5, and 8 to orange. So 2, 5, and 8 is now going to be orange. 2, 5, and 8 is now going to be orange. And we're going to get 3, 6, and 9. We're going to get 3, 6, and 9 all to be purple. 3, 6, and 9 is now all going to be purple. So we're going to get 3, 6, and 9 all to be purple. Okay, the 8 was orange. Okay, now according to, how come I don't see this over here? The 8 is supposed to be orange. Why didn't I get orange? Okay, so now, whoop, the 9 has to be purple. Whoa, got to take that out. I got to do it in here. So this, okay, what is this? This has to be purple. So now what we have is this is Tesla's power energy. So now that I made this board, I know it's taking a long time. There's a lot of work involved in this. That's why I'm not finished, because I need to be able to do this so it's all equal, so I can see it equally. Now what I have to do, okay, is I have to take this entire square again. I have to copy it, and now I have to start putting them next to each other. Okay, to create the power grid. One here, then I'm going to have to put one down here and put one over here. And this is going to make a new power grid reality. Okay, and if you notice, the center has that same energy. That's going to be our separation. As you remember, I'm going to take this away now. Okay, that when I did the small one down here, I could have separated the top and the bottom. I separated all 4 sides. Once I put this square here in the center, I could have moved these 2 sides over, and I could have moved these two sides up. I could have did either one, either or. So either I would have had 6, 1, 6 and separated them that way, or I could have had 6, 1, 6. You follow? I could have kept either this line and separated the top from the bottom, the heavens from the earth, or I could have separated the two worlds. I'm not sure which one to do. I have to do both. In one scenario, okay, because of these numbers of squares, it would have been 36 and 36, 72, plus 6 is 78, making for the gateway. Okay, 78, okay, and 78, making for the gateway, above and below. Not counting these, What I'm going to show you is what I would do is it would now come together like this. Okay, so it wouldn't look the same anymore. Okay, so now, although I have a dot that separates the center, this dot that separates the center, okay, is going to be halfway between the two. Is that what we're going to call the moon? And if that was halfway between the moon, we now have 2, 4, okay, 5, 1 in between both of them would be 6, okay. I only have 1. I'll have 2 here and 2 here is 4. 2 here and 2 here is 4. Okay, 2 here is 4. I'll have 2, 4, 6, 8, 10. I'll have 12 of them instead of 13 now. I'll have 12 instead of 13. I'll have 72, 72, 72, 144, and 12, 156. Okay, but that's not what I did. I end up with 169 with the numbers in the week, right? 616, and that's what the cube tells me, 616, and that's why I separate it right that way. Now I'm going to show you something else in here. Okay, in the first one, okay, I put all the ones in the center, right? Bringing me 4. I have 5 in the corners, bringing me 4 total, 4, 20, and 36, or 4, 2, 9. In this one, I put the 9s in the center, but no matter which one I do of all of these 3, the 5s will always be in the same place. The same way that the 5 ball, okay, in pool is orange, the same way that the 5 is a very special number. The 5 is always red. When you play roulette, the 5 is red. There's another scenario where the 5 never changes colors. The 5, Jupiter, never moves in numbers. And the final one over here, okay, is where I flipped, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I kept 1, 2, 3, 4, 5, 6, 7, 8, 9 in continuation. And then when I flipped it over, I went 1, 2, 3, and 1, 2, 3 that way. When this happens, okay, when this happens, what happens, in fact, I probably shouldn't even talk about this one. I should stick to this one and show you something different, but I'll explain to you. In this one, we go from 9 all the way to 9, encompassing 7 and 8, and we go from 7 all the way to 7, encompassing 9 and 8. So where the birth comes in the heavens, the gateway comes into the heavens. And this is the way this one is set up. In this scenario over here, okay, that I'm going to set you up, I'm going to try and explain it to you. Now, because I'm a single person, and this is my excuse, because I'm that single person, I seem to not be able to get it out of my head exactly what it is. I will show you something with green colors. Okay, and I'm going to attach, because birth is 9, I'm going to attach 9 over to 7. I don't want to do it that way. I want it no feel. I'm going to do it with a little bit thicker of a line so we can see it. I want to take 9 and put it over to 7. Okay, and I'm going to take the other 9 and put it over to 7, encompassing gateway to birth on both sides. Okay, now what I'm going to do, okay, is I'm going to take 3 over to 3, Okay, did I do that right? I'm going to, is that what I did? Yes, that's exactly what I want to do. I want to encompass 3 over 3. I want to encompass 7 over 9, 9 over 7, and I end up with this design over here, breaking apart the corners of 5. Now in each corner I'll have 1, 2, 4, 5. I'll have 1, 2, 4, 5 here. I'll have 1, 2, 4, 5 here, and 1, 2, 4, 5. 5, 1, 4. Inside the sun is the creation of birth. I'm not really sure which way I went with this, what you're going to understand, but in this scenario, okay, there's 36, 36, 36, 36 areas, 144, 144, but in this one down below that I did at first, there was 168, 1,440 minutes in a day to the time clock, 168 hours in the week, and this is the Monopoly board. I want to thank you for watching this really, really long video where I'm not quite sure what we got across in it, in scenario number 1, I went over and encompassed 1 and 3, okay, which is AC. 1 and 3, how can I explain it? Man, I don't even know which way to explain it. There's so many things. But anyways, let's leave it at this for now. After I do something, sometimes I polish it off, maybe in a day, maybe in a week, maybe in a month. And don't hesitate. I will really appreciate it. And thank you for watching this video. TACPANS, TACPANS at msn.com. Thank you for watching this video.